Alright, good morning ladies and gentlemen. My name is Ali and today I'm going to show you how to assemble a gear assembly in Matlab Simulink and how to get some variables and values out of that gear assembly. So in this file over here you can see that I have two STL files, gear number 1 and gear number 2, and I actually have another video where I show you how to create this gear assembly in Autodesk Inventor. If you want to go watch that to see how exactly I made these gears that perfectly mesh with one another, you can go ahead and check that out. Now let's get started. So the first thing you need to do is download yourself Matlab if you don't have it. And the reason you need to download Matlab is because you need simscape multibody. That's the thing. So if you go to Google and you Google simscape multibody, and it should take you to the Matlab site. And this is the page for simscape multibody. I'm sure you can find it on your own. So what you're going to do is download the trial. So you export the features and then get the trial software right here. And if you're a student and whatnot, you give them your email address and you agree to this. I have already done this. I just want to show you quickly how to get that. So it will give you a 30-day trial. You'll select the Matlab version that you have and your operating system. And here are the trials that they'll show you. And this is the one that you need. You scroll down to the very bottom and you scroll back up a little bit. So simscape, that's the one you want to get, and then simscape multibody, and obviously they have other options. So these are, and you just click here and download and install the trials for that. Okay, so now another thing is this page right here in Matlab. That's I have bookmarked. This is also a guide on how to create gear assemblies, and they show you different ways, and this is what I've actually learned from. So if you want to learn what I have learned, you can go to here. I'll have this link to this website in the comment section below, or I'll post the link to it with that video. But basically what I'm going to do today is teach you how to get this done the way they did. Now, when you open Matlab, what you want to do is select the folder and make that as a directory. So the folders that the gear STL files are in is obviously here, right? It's these two gears. And so when I go and open Matlab, I want to go to desktop, this file right here, and hit select folder, and it will load it up here. And here you can see the two STL files. And this is the Autodesk Inventor assembly file. So then next thing you do is you hit Simulink, right? And to get started, let's create a blank model. Alright, so we'll minimize Matlab. And this is Simulink now. And in Simulink is where you can create your assembly. Now, mind you not, Simulink is a two-dimensional representation of a three-dimensional gear assembly, which is what you're trying to make, or it could be a two-dimensional assembly connected by lines of various systems. So once you hit this, this little button right here, this is your library browser. This is kind of like where the individual rectangles are that you can import. So commonly used blocks, for example, if you want to do 2 + 3 in Simulink, so you bring a constant in here, and this is going to be just a quick tutorial. So we double click this, right? This interface is pretty intuitive. So when you double click this, this pops up and it tells you about it. So we'll make this number 2, okay? And then we want another constant that we'll just click and drag in here, and we'll make that 3. So 2 and 3, and we want to add them together, and that's with this sum right here, right? So this, and all I have to do is connect it, right? 2 plus, so obviously we know the answer is 3, and a visual output in MATLAB is called a scope. So you can actually search things here. So scope, and scope pops up, and you just hit that and you connect that line. So you have to imagine if this, instead of a regular number, it was like a voltage difference, and this was maybe like another voltage difference of a different system, and you want to add them together or separate, or look at the differences of them. You know, you can have plus plus, that just means plus plus, or you can do plus or minus, right? It changes that. So what we just want to do is add 2 plus 3 and see what the output is. So this is, and then you just hit play, right? And it'll do its calculations, and then you double click the scope. Oh, it's calculating right now. And it'll have that nice sound. That means things are done. And you double click the scope, and here's the scope. So 2 plus 3 is obviously 5, and as you can see, the signal is constantly at 5. So within 0 to 10 seconds, 2 plus 3 has always been 5. All right? And you just highlight all of them and delete them. So let's get started. The first thing you need to do is convert your gear assembly into step files. So I can double click here, so the orange gear, and everything is shut down except for the orange gear, and I will do File, Export, CAD format, and right here are the STL files for the gears that I have on my folder on my desktop. So I will convert that into step files. And right here. Okay, so let's call this gear 2. Okay, and then what I will go over is to the other gear and double click that one, and File, Export, CAD format, and step files, and let's call this one gear 1. Okay, now if I go here, I have my two step files, right, my 2 STL files. So a step file is pretty much just numbers and words that tell you what a 3-dimensional object is, and that is what you want in order to convert your parts into Matlab Simulink. So we'll go here and once again open Simulink. Now what you want to do is hit simscape, since you've downloaded that, and then open up a multibody. So that presets everything for you and allows you, let me minimize MATLAB, and allows you to create an array, and it does kind of some of the work for you. So this function right here is one of the blocks that does all the dynamics equations for you. And this one is a block that creates a 3-dimensional world. So and it's called the world. So if you double click it, it says world frame, and there's some information about it. And over here, this is kind of like a mechanism configuration, and this is where gravity is. And for our sake, to make things a lot simpler, we'll just set gravity equal to 0. Just so nothing falls apart. Now this cube right here is a rigid transform, and if you hit this button right here under so if you've downloaded the simscape multibody, you go to simscape, and under multibody, right? So under simscape multibody, you'll have frames and transforms, and this is a rigid transform right here. So if you just click that, it'll bring it, and you can just drag that into here. And this rigid transform will allow you to assemble things the way you want. So solid 1, let's rename that. Let's call this gear 1. Right, and if you want to put in another gear, you will go to body elements, right, and find solid 2. So let's say you didn't know where things were, you just come in here and search for solid, right, and you hit enter, and it will search things that have solid in them, and chances are you'll find what you need. So you just drag a solid into here. So you double click the solid, and As a default, every solid is a cube, right, or a brick. So what you want to do is choose from file, right, and that's a step file that we want to import, and the file name is where you can select the step file that you have. So gear 2, and the graphics of it, we'll change that and make that a blue gear. Hit OK. So now let's rename that to gear 2. Alright, so now if you open up gear 2, it's loading right now. So it's a blue gear. Alright, now gear 1 is still a cube, so what we'll do is select from file, and we'll change that to step file. I can import STL files, but step files work better. And we select gear 1, hit OK, and in the visualizations we'll change the color. Let's make that a nice orange gear. Alright, and there she is. Okay, and then if you want to arrange these things, so if you just hit play right now, there's that sound that says we're simulating something, and there's nothing going on really right here in the simulation box. So what we can do is just attach things to one another using the lines, and that's kind of where things get tricky, because you're using a two-dimensional representation to change something three-dimensional. So let's see what happens with this. All right, as you can see, everything is at the origin, right? So our orange gear is right in the middle of the blue gear. Now, and using this cube is where we can translate things and move things around. So now gear number 2, if we recall, let's see, has a radius. Gear number 2 has a radius of, or has a diameter, so this D right here has a diameter of 4.52 inches, right? That's the bigger gear. I know over here it's called gear 1, but I've just mixed up the naming. So the bigger gear has a diameter of 4.52 inches. So if we go back to our Simulink, model right here, we can translate this gear. We can just move it over standard axis. So if you knew the Cartesian coordinates and all that, I'm not so three-dimensionally aware, so I'm just going to slide it over the x-axis in a positive direction, and so I'm going to slide over by its radius. So 4.52 divided by 2, that makes it the radius, and inches, right? Hit apply and OK. So now if I press the and go, so the big gear has moved over some in the positive x direction, right? So here's your xy coordinate system. Now we need this one to move over by its radius as well. So that is the little gear. And if we go back to see what the specifications for that little one were, so the diameter of it is 1.48 inches. So I need to move it over half of that value. So I'll come over to my, let's close this, to my Simulink model, and select this rigid transform, and I'll translate it, use standard axes, and remember we moved the other one in the positive x direction, so we'll move this one in the negative x direction. And that is 1.48, which is this dimension right here, this diameter, divided by 2, which makes it a radius, and my units are in inches. So apply and OK. So now if we hit the simulation, you can see they are where they need to be. However, they're not perfectly geared, meshed up right here. But that's no problem. I can just go back to this rigid transform, and rotation is an option also. I'll rotate it around the standard axis, and that is the z-axis, right? If you kind of can look over here, right here, you can see that the z-axis goes through the center of this. So we'll change it by an angle of 6 degrees. Okay, and hit the simulation again, and as you can see, it's meshed up pretty well. 6 was a little bit too much, so let's go back to, let's say, 5. Okay, that's much better. All right, that's actually pretty acceptable. Okay, so you have your two gears in the right positions, and they're perfectly meshed together, right? Now, you want this gear to be able to rotate around its axis, and so is that one. Now, so that means the next thing you need to import, right? We'll just click this, and we need to import a joint, right? So now, if you go to simscape, and then gears and couplings, select joints, there are various joints you can pick. The one we need is a revolution joint, so it's called revolute, so we'll bring 2 of them in here because we want both gears to rotate around the right axis. So we'll just quickly delete these lines and include this revolution joint in the middle. Okay, so that just means wherever they are, they're just going to rotate around the z-axis, and it tells you that right here. Coincide in the z-axis and base follower. So you see, it's just telling you whatever you have is going to be rotating around the z-axis unless you tell it otherwise. So let's hit the simulation. And you see things are still the way they are, but these are joints, they can rotate, but nothing is still happening. So in order to make a joint rotate, what you need to do is actuate the joint, so provide some torque here. So that's easily done by double-clicking a joint. So let's see, this is the big gear. We want the small gear to drive, right? So we go to the joint of that small gear, double-click it, and actuation, right? That just means put things in there, put things into the joint, move the joint. We'll say provided by an input, and the motion is computed automatically, and then we'll just hit OK, and it creates a new tab right here. That just means we can put some torque in here, just like we said, actuation, torque provided by an input. So here's that input. Now, the easiest way, if we trace back, is we can import things through whatever a different signal, but we'll just pick a constant, right? We'll just search for constant here, and it pops up one of these things, and we'll put a constant in here. We'll change that number to 20 because we want 20 pounds of torque. Okay, that's just an arbitrary number I picked. So you cannot connect this 20 in here because it doesn't recognize it. So 20 is just a signal, but we want it to be a physical signal, and that's exactly what this box does, right? If you want to get this box, you just look for signal, search for signal, and it should pop up here somewhere, right? Or let's see, if you can't spell physical signal like I can, you go to simscape, multibody, or simscape, and then go to utilities, and here they are, right? So we'll bring a signal to a physical signal in here, right? So you connect the 20 signal in there. Now it's converted to a physical signal, and that physical signal is a torque, right? And that you can send in here. So if you hit play, you can see that there's 20 pounds of torque applied to this guy right here, and it's rotating. Okay, it's being actuated. And but as you can see, this guy is still not. Let's rewind these 10 seconds. This guy is not moving whatsoever, and that's because they're not actually. simscape doesn't recognize that as a gear. Now, if you want to know what this joint is doing, which is also important, we'll double-click it and we'll hit sensing position, so we can sense the position that that gear is in, right? And that's an output, so that's a physical signal. And right here they have PS to S, which means physical signal to regular signal. So I'll drag these two down here and connect it. Okay, so if you run the simulation again, you can see this shows you that this is how much this gear has been moving. So at 0 time and 0 seconds it was here, and because of the torque that we put in, it constantly increased its position, right? Its angular rotation. So now we want to relate these two to one another to be gears, and this is where the cream of the crop comes in. So we go to here, simscape multibody, gears and couplings, and then select gears. and then common gear. So here are different options that you can pick: bevel gears, common gear ratio, bracket and pinion, and worn gear. So we'll pick common gear because that's what we have. We put that right in the middle, connect the base right to this line, and then the follower goes to here. And so this will automatically say that if this is rotating, this should rotate, but by how much? So in here you can tell it exactly. So you can select if it's external, internal gears, so obviously an external, specifications, center distance, and ratio. But we knew the radii of the circles, right? So we'll select that, and our units are in inches. So by giving it the two different radii of the gears, it will simulate the gear ratio and make sure that the torques and the forces and the positions are according. So, and to remember what our gear radii are, so this is the base, which is the B part, and that's connected to here. So if I go to my transform and remember how far I translated it over, which was the radius of it, so I'll copy that number, Control C, and then paste that number into here, Control V, okay, and then the radius of the follower, let's go to how I translated by 4.52 divided by 2, which was the radius. So copy that by holding down Control C and then pasting that in here, Control V. And the units were inches, and I hit apply. So this is all it needs to know, that these two are gears, and I hit the simulation one more time. And there we go. Both are turning. All right, it's a little bit off just because my graphics aren't that good. It's a little bit laggy, but you can as you can see, it's rotating the wrong direction. Now one way to fix that is center distance and ratio. So the center distance of the two, if we go back to our drawing, we can see that our center distance was 3 inches. So we'll give that in right here and say 3 inches. And the gear ratio we can see was 113 teeth to 37 teeth. So we'll do 113 teeth to 37 teeth, and that should be 1 to 3, very roughly 1 to 3. It will, just because the number of teeth are off, it will not be exactly 1 to 3. It will be very close. Okay, so this is probably the better number you need to put in. So hit apply. Okay, let's go back to our Simulink model and press play. Oh, it said it didn't like that. So let's do 37 divided by 113. Let's try it again. But however, there you have it. Let's see, maybe if I go back to this option and hit apply, let's see, that should still be the same thing. I'm pretty sure these gears are meshed just fine. Just my graphics aren't that good, and if not, you just need to mess around with this. Maybe exchange those numbers. So and change this number. Just change those values, and there we go. And sometimes you have to tweak things to make them work. So now you can see that this gear moved this much, and if you want to see how that affected the other gear, you'll double click here and you do sensing and you select position, right? So it'll spit out the position of the other gear, and let's copy this and paste it here and connect that and run the simulation again. So now you can see how this gear is moving in the opposite direction or rotating in the opposite direction with respect to this one. And you see this turned 4 times, let's say that it's 4 times. It turns 4 times, and this one turned way more than 4. So it moved almost 3 times that much, to be specific. All right, thank you very much for watching this lecture. I hope you learned something. Until next time.